Hey guys, Coach Sharf here. So this is video number 5 on the first packet from last week. This is being recorded on Monday night. I told y'all I'd give y'all the weekend to finish it. I also talked about it a little earlier in my Instagram live. So we're gonna run through the last 11 problems of this packet, and then I'm gonna quickly talk about the upcoming work, even though I sent messages out and remind earlier. So let's just go ahead and jump in. Number 45, Carlos constructed 3 parallel lines as part of an art project. He drew the line passing through each of the parallel lines, which is acting as the transversal. Again, we briefly talked about 3 parallel lines. They have the same properties as 2 parallel lines with the transversal. So when you look at the diagram and then it's your 4 answer choices, A says angles 1, 2, and 3 are congruent. Well, obviously 1 and 2 are not. They're a linear pair. 1, 3, and 5 are congruent. They're all 3 in the upper left-hand angle of the intersections. So that seems to be the correct answer. Let's just check the other 2 real quick. 2 and 4 are supplementary. Again, those are in the upper right hand, so that's, I forgot to say the relationship on the last one. Those correspond as 1, 3, and 5 do. Corresponding angles are congruent, not supplementary. And 1 and 5, same idea. Even though we skipped down here, it's still in the upper left, so they still correspond, which would be congruent. So our answer choice there is B. All right, 46. Martin built a box to store his video games. The box is shown below. Martin needed more storage and built a similar box with 1/3 each of the length, the width, and height of the first box. By which factor does the change in dimension between the 2 boxes affect the surface area? So again, we've talked about this. Each side is getting reduced by 1/3 of the length. So then we just got to, it depends on if we're talking which unit of measure we're talking about. If we're just talking about just straight measuring something. I just lost my lid on my marker. That's what I'm looking for. That's why the camera's moving a little bit. Over that. There we go. All right. Anyway, so when you reduce the dimensions, the lengths of any thing that you're measuring, and it corresponds with perimeter, area, and volume. Perimeter is the same, so if all your dimensions are reduced by 1/3, your perimeter is reduced by 1/3. Area and surface area is the same. Again, remember, surface area is just the area of this rectangle, the one on the opposite side that's the same, the area of this rectangle up top, the one on bottom that's the same, the area of this, again, it kind of looks like a square, but it's 6 by 8, so we still know it's a rectangle. The area of this rectangle and the one on the other side. So all 6 areas added up. But it's still area. So we would have to square whatever the scale factor was, which in this case is 1/3. So it would be 1/3 squared, which is 1/9. So my answer would be C. If y'all really wanted to work out the math, again, if you can't remember that, what you do is draw a similar box. Okay, I'm drawing it 3D over here. I'll show it in a second. All right, so we need, all dimensions are 1/3 the size, right? So 12 reduces to 4, 6 reduces to 2, and 8 reduces to 2 and 2/3. 2.67 if you divided it. So there we go. So if we look at my original one, I've got 2 rectangles that are the front and the one that's facing us and the one behind her, 12 by 6. So it's 12 times 6, which is 72, and then there's 2 of them, front and back, so that's 144. You got top and bottom, which would be 12 by 8, so 12 times 8 is 96, times 2, 192. And then you've got side and side, which is 6 times 8, which is 48, times 2, since there's 2 of them, which is 96. So there's that. That looks like a 7. We add that all up, we get 2, carrier 1, 29, 33, 432. All right, so that's our surface area of this one. So what we get for this box should be 1/9 of that. All right, so for this one, we got front and back, which is 4 by 2. this 2 right here. So 4 by 2 by 2, which is 16. Okay. I've got top and bottom, which would be 4 times 2 2/3 times 2, which actually multiply that out. It'd be 16 16/3, so 21 1/3. And then the left and right would be 2 times 2 2/3 times 2, which again in my head, let's see here, would be 4, so that'd be 8 8/3, so that'd be 10 2/3. I add all that up, that would give me 1. So I've got 1, 11, 32, 48. So 48. So let's see what happens if we divide 432 by 9. Again, I'll just do it here. I could put it in the calculator. 9 goes into this 4 times. 9 times 4 is 36. 72. 9 goes into 72 8 times. 72, 0. Yeah, so we did get 48. All right, so it does match up. So it's 1/9. C. All right. 47, we're going to skip. We're not required to teach that one to y'all, so you don't got to worry about it. If you're curious, it's going to be what you wind up having is 2 pyramids with a triangular base. One would be pointing up, one would be pointing down, and they would be kind of stacked. The answer would wind up being 12. Again, you don't really need to know that. See my pinky getting in the way there. All right, 48. Translation. All right, again, going back to earlier in the year, but pretty easy. So what is the translation image of the triangle shown? So that's our original image, or that's our pre-image, rather. Use correct terminology. That's our pre-image. So what is the image after we use the rule x minus 3y plus 3? So we move the triangle 3 to the left and 3 up. So let's see which one that is. A goes right and down. So that's not it. C goes left and up, so that looks promising. So let's see here. This is it. It's counting by 2s, right? So this is at -4, 1. So we go left 3 would be -7. And then up 3 would be 4. Yeah, so there's that one. Other points should match up too. Let's just double check the other ones to make sure it's not C. Yeah, this one goes down and left. This one goes up and right. So C is our answer up here. Okay? All right. 49 again. Don't teach y'all what tessellations are, so don't worry about it. 50. All right. Which of the following be enough to prove that quadrilateral QRST is a parallelogram? We did learn about parallelograms. So again, the 4 rules about parallelograms are the pairs of opposite sides are congruent and parallel. That's the rule 1. Opposite angles are congruent is rule 2. Consecutive angles are supplementary is rule 3, and the diagonals bisect each other is rule 4. So if we look at our answer choices, line segment QR is congruent to line segment ST. So there and that. So I got one pair of sides is congruent to each other. That's actually going to be true for any regular quadrilateral. Any regular quadrilateral has one pair of sides that are congruent. A regular trapezoid, the 2 diagonal sides are congruent. They're not parallel, obviously, but they're congruent. Square, rectangle, rhombus, a regular kite. Again, we didn't really learn about kites, but all those have at least one pair of sides that are congruent, so that's not enough. B, QR is parallel to ST. Well, again, pretty much any quadrilateral except for a kite has at least one pair of parallel sides. A regular trapezoid, the top and the bottom. Square and rectangles and rhombuses all have 2 pairs of opposite sides that are parallel, so that's not enough. C, QP is congruent to PS and TP is congruent to PR. So that's QP, PS, TP, and PR. That is our diagonals bisecting each other. Okay? So, again, you need additional things to show that shapes are a rhombus or a square or a rectangle, these could apply to a trapezoid. That's really the main thing here, all right? Again, we learned, if you really think about it, a rhombus is a parallelogram that looks like this, but all four sides are equal. A rectangle and a square are both technically parallelograms as well. On all of those, the diagonals bisect each other. So this is the one thing that makes it different from, say, a trapezoid. So C is our answer. Okay? All right, 51. What is the converse and the truth value of the converse of the following conditional statement? I gotta see if I have it written down. I showed y'all where converse was in the first video in your book. I think it's lesson 2.1 in your Big Ideas math book. And again, you can look that up online if you need to. I do have converse at least written down right here. All right, so conditional statement says is an if-then statement. If A happens or A is true, then B happens or B is true. The converse, we just flip the two parts, okay? So our original statement is if an angle is a right angle, then its measure is 90 degrees. So we just got to flip those. So that automatically gets us down to C and D, okay? And then its truth value. Well, is that statement true or not? If an angle has a measure of 90 degrees, then it's a right angle. Obviously, that's true. So our answer is D. All right. Finger getting away again. All right. This is going to be the one that we got to do a little bit of math on. The figure below, NP is the altitude drawn to the hypotenuse of MNO. If NP is 9, which is in there, and MP is 15, which is also in there, what is the length of OP? So we want this little segment right there. So we can work around this, and it's going to take a little bit of math. But alternatively, actually, we could do this pretty simple. We don't even do a little bit of math. When you have three right triangles drawn like this is a right triangle again, because this would be a right angle as well. This right triangle, then the whole thing. Okay. When you have the altitude drawn right there, we talked about altitudes a little bit when we talk about the triangle segment theorems. All three of those right triangles are similar. Again, this is something we didn't explicitly go over this year, but all three of these right triangles are similar. Okay. Obviously, they have the one right angle. The other two angles match up, and the sides increase or decrease by the same ratio. So, if we look at the middle-sized triangle here, not the big one, we have a short leg of 9 and a long leg of 15. So I'm going to set up my ratio like this. I want my short leg up top, my long leg on the bottom. So my short leg for the one triangle that we're given is 9, my long leg is 15. But now if I look for the small triangle, my long leg is now the 9 and OP is my short leg. So OP is my short leg, so what I'm looking for is X. My long leg is 9. So again, it's just two similar triangles, okay? We talked about similar triangles, so I set up the ratio. Again, hopefully y'all know what to do next is cross multiply, which would give me 15x equals 81. I would divide by 15. And x would be 5.4? Yes, 5.4. So answer choice C. All right. 53. What is the value of x? Again, something we didn't explicitly go over. This is really shooting at the exterior angle theorem. Okay, all the exterior angle theorem says is that if you have a line extended out past one of the corners of a triangle, this outside angle has to add up to these other two. Well, why is that true? Well, 105 and this angle in here form a linear pair. They add up to 180 degrees, right? All three angles in the triangle also add up to 180 degrees. So those two angles and all three of these angles got to add up to 180. This angle is going to be the same for both, right? This angle is going to be the same for the pair with 105. This angle is going to be the same for those. So we get rid of that angle, okay? So then that has to tell us that this angle has to add up to those two. But again, if you don't want to necessarily remember the exterior angle theorem. We can go back to, it's still basically applying the same thing. This is a linear pair, right? So if I draw this out, hard time drawing with one hand while I'm holding the camera recording. I know it's a little off. All right, so if that's 105, again, that's got to be a linear pair, so I know that this has to be 75. It adds up to 180. This is 72. This is x. Again, I know these, all three of these got to add up to 180. So that's 147 plus x is 180. Subtract 147 from both sides, so x would be 33, which is A. And again, if you want to apply the exterior angle theorem, I feel like I'm slurring it a little bit. If this is 33, 72 plus 33 is 105, which is what is outside. All right, 54. So we did this semester, or actually we did this just a few weeks ago. We got angles. These are actually all inscribed angles. Again, the angle is on the edge of the circle, and they open up to the arcs, right? So I know this arc is 120, okay? So there's a couple different ways to go about this. I think this is I'm gonna go the shorter way. Since this angle XVW opens up to this arc, again, if you get rid of that line, it would just be that angle and that arc. This has to be half of that. So this angle is 60. So I'm just going to draw a triangle by itself now. Again, I know it's not the best triangle. I'm trying. Here's 57, here's 60. So that has to be the angle to make it out to 160. It would be 117 plus x equals 180, like we just did. So x would be 63. You could go a different route, depending on what you remember. It still has to do with inscribed angles, but now you might say, instead of figuring out that x 60, you're going to say, okay, I know that that's 120. This is 57. It opens up to that. So now I have to double the angle to get it out there. And this is going to be a little longer, but y'all just follow me for a second, okay? So here's x. I'm drawing it real quick, then I'll show y'all. Here's w. Here's v. All right. So this is 120. All right. We got double 57, which is 114. So that's going to go up there. All right. And now again, now we got to do the whole circle. Now we're just looking for VW, because if you look, VW is this arc. VXW, which is the angle you're looking for, opens up to that arc. So if we can figure that arc, we could take half of it and get that angle. So you add those, it'd be 234. So to get the other one, I would do 360 minus 234, which is 126, right? So this arc is 126 degrees, which means that angle is half of that, which is 63. So either way we did it, we got 63, okay? And 55, we didn't talk about trapezoids or mid-segments, so again, we'll skip that one, not have to worry about it. All right, so there's the whole first packet. Again, just get all the work I showed y'all. This last packet didn't have, or this last section didn't, only had a couple problems where you really needed to show work. Get it all down when you can. Again, assuming we're back in school before the end of the year, I will take it up at some point for a grade. I also posted, and I'll quickly show it here in case you don't see it on my YouTube channel. I didn't do the front side of the first page for the volume worksheet. But here's the volume worksheet. I just did a video where I did these problems and these problems. I stopped at the word problems. I'll do a separate video on those later. So I posted that one earlier today. I don't think I sent out a message about it, even though I'm about to now. And so you need to finish up this packet. And now what you need to start working on is this packet. Again, I'm going to show it. I showed it in my Instagram live earlier. This is the one I gave y'all in class 2 weeks ago. The last week we were there, the one I told y'all that y'all needed to do in your world history classes. I will post it on Canvas. Some of y'all didn't get it. I know I had a few leftover copies. I will also
send out the PDF on Remind. And I think some people said they were still having trouble seeing their work on Canvas. Even though some people were telling me a week late during the Instagram Live today, they didn't say anything for a whole week. But anyway, so I'll get all that done. Y'all start working on this tomorrow. I'm not going to post unless I finish that volume worksheet. I'm not going to post anything on this tomorrow. So y'all need to start on this tomorrow. It's 30 problems. So what you need to do is 8 problems tomorrow. If you want to spread it out over the week, 8 problems tomorrow. You can go ahead and show me your work tomorrow, but you have until Wednesday evening to send me that. You need to do 8 problems on Wednesday. Forgive the dog, I'm sorry. It wants to go out and it's raining. You need to do the next 8 problems on Wednesday, although again, you have until Thursday to send it to me. So that's 9 through 16. 17 through 23, which is 7 problems on Thursday. But again, you have until Friday to send that to me. And then the last 7 problems, 24 through 30 on Friday. And again, I don't know if I'm going to post the last video on Saturday night or wait until Monday like I did for this one. I will let y'all know. But again, you have until, I would go ahead and do the first 8 problems tomorrow and send them to me. I'm giving y'all a little extra time to work on it before I post the video. So again, you still have up until Wednesday evening to send in the first 8 problems, but that's when I'm posting the video on that. So again, you need to start working on this tomorrow. I'll post the first 8 problems Wednesday. Again, give y'all a day to kind of get started on it. Next 8, I'll post the next 8 Thursday, the next 7 Friday, and then either Saturday or next Monday, the last 7. But again, go ahead and start working on it tomorrow. So y'all have a leg up on it. Y'all can send me questions. I didn't really have anybody send me questions while y'all are working on it. Send me questions while y'all are working on it. Yeah, so that's it. Again, if you got any questions, send me a message on Remind. Other than that, I'll see you guys later. Peace.